I don't know about that. Okay, so, anyway, so the period of a pendulum, and they're telling you that it's the time it takes to complete a full swing cycle. Think about it, you know, we looked at that one of the Japanese pendulum, the world's largest. That's obviously going to take a much longer time to go from one side to another compared to if you have a grandfather clock, maybe that's 6 feet long, or some people have little kitchen pendulums in their kitchen and it's swinging back and forth. So the period follows, depends on its length, makes sense. So if L is in meters and the period P is in seconds, we have this formula. Okay, was everybody good with that? Okay, where it's 9.8 times P over 2 pi squared. All right, they're giving you that information. Write the equation in the form L of P equals AP squared with A rounded to the nearest hundredth. What do you think you're going to have to do? Are we solving for P?
Yeah.
We're writing this equation. What does that mean? What are the directions asking you to do? Solve for P?
No, wait.
No.
Put it in that, like,
Just put it in that form. And how do I put that in that form? Anybody have any suggestions?
Use your
Get rid of the 2 pi. Good job, Caitlin.
use Kristen.
Kristen? Okay, sorry, Kristen. Okay, so could we figure out what is 2 pi equal to, roughly?
6.28.
6.28. So could I say 9.8 times P, and what does this exponent do to everything that's inside of there? Squared, so it's P squared over 6.28 squared. Can I continue that?
Yeah, you end up with
Simplify? And what would you get? You do it, you're doing the work.
9.8 oh wait.
Right? So all I've done is simplify. They've asked me to simplify that equation. Did you get that, Jackie? Good job. Let's see what you got. Well, these guys are probably testing. Did you get it? You did get that too. Anybody?
January 36.
If my calculating all came out right, like somehow
Where are
it
you?
did.
6.28.
I bet it's going
Yeah, I
to
don't
be
think I did the,
36 points.
Yeah, January 36.
39, oh my god.
No.
Why?
Okay? So, if you have 6, so I'm ending up with 9.8 times
I
P
know what happened.
squared over, what is 6.28 squared?
39.
39.44.
39 what?
0.4.
Point
I
4.
squared the pi before I multiplied by 2. That's what I did. Which didn't make any sense because it's
Okay.
in parentheses first.
Okay, so I should have, all right, if I had this problem, if I had 8x over, let me see, 8 times x over 4, how would you go about solving that?
Multiply the numerator.
First time multiply by 8, then multiply by
Well,
whatever's on the bottom.
this says 8 times this quantity, yes? Does that equal 8x over 4?
Yes.
What would you do then?
Multiply by 4.
Why are you multiplying
Divide
by
by
4?
That's all I
Aren't we just dividing by 4? 8 divided by 4 is 2? Yes? Everybody agree with that? Okay, well, why is this problem any different than this problem?
It's not.
It's not. So what do I need to do?
9.8 P is
9.8 divided by,
Multiplication.
39.4.
and what will your answer be?
0.25.
Okay.
9.8 divided by 39.
This says 9.8 times this quantity.
Yes.
Okay? what does this problem say? 8 times x over p. I just made up a problem with a variable in the numerator. Variable in the numerator. Does this say 8 times this quantity?
Yep.
And does that equal 8x over 4?
Yes.
Okay? How do you simplify 8x over 4? I'm dividing 8x by 4 is 2x. Yes? No?
Yeah.
I mean, is that algebra
But when you
1?
get 9.8 p squared.
Okay, well, why is this any different? It's not. So I'm going to divide 9.8 by 39.4, and it's 0.25 p squared. Okay? Did we now write the equation in this form? Do we have a variable, our a, in front of the p squared? Okay, is it going to be a quadratic?
Yes.
Okay. Is it going to be slow? Think of it. Remember we talked about the value of a? We have 0.25. Is that going to be a pretty shallow, it's going to be a shallow graph?
Yeah.
Okay? All right, so write the equation in the form, all right, we did that. Without graphing, compare the graph of L of p to the graph of f of x equals x squared. Well, what is the numerical coefficient here?
1.
1. We just kind of answered that question. So this is going to be what compared to the other one?
Wider.
This is going to be much wider. Okay? Doesn't that make sense? That's going to take a long time for that. All right. Let me say, what pendulum lengths correspond to the periods of 1, 2, 4, and 8 seconds? Well, what pendulum lengths? How do I find what the length is?
Like you plug and chug.
I can just plug and chug at this point. Okay? All right, so in retrospect, is this word problem really challenging?
The last one's confusing.
Okay, well, let's look at if you want the pendulum to swing from side to side, this one is confusing. If they're saying that the whole, what do you call it, period, is from here and back, and if you want the pendulum to swing from side to side 1/2 of a period in 1 second, how long should the pendulum be?
And then you just find for
Very
2
long.
seconds.
Right.
Okay.
So you just double it and then figure out what it would be for 1. Okay? Because you know that half of we have the formula for a whole period, but if we only want it to go for half a period, then we find what it is for a whole period and take half of that. Okay, so that was just the wording of that. Okay? So it's called keeping you on your toes, getting your little brains thinking.